So the question says that the ladder is uniform and it is of mass 17.5 kilograms, meaning that its weight acts in the middle. This is 1.5 meters, 1.5 meters. The weight acts in the middle. And the weight is mg, so it's 17.5 g. They're saying that it is resting against a smooth vertical wall. So if this is smooth, we say that whenever the wall is smooth, then we normally have a normal reaction at that point A. I'll call that one point A. So it is end A is against a smooth vertical wall. And then end B is against a rough ground. So if this is a rough ground, that means that the reaction always acts at an angle. It is not a normal reaction at point B. So since it is rough and it is tending to slide this other side, then there must be a frictional force which is opposing that motion. And that frictional force acts in that direction there along the ground. That is our F. So our F is given by mu times the R, and R is the normal reaction at this point here. I'll call this one my normal reaction, RB, like that. But remember that since it is rough, the normal reaction acts at an angle. It can be here. I mean, the reaction acts at an angle. It can be there or it can be here, anywhere. The angle will tell us where that reaction is. And that reaction is the resultant of the RB and then the frictional force. Okay, let's try to do this together. So, applying the conditions for body to be in mechanical equilibrium, vertically, we shall have that our weight is the same as RB, 17.5 G. So this is almost 17.5 times 9.81. You get the answer in newtons. That is the reaction at B. Then horizontally, we shall simply have it that RA is the same as our frictional force. In other words, what I'm using at this point here is that the sum of the forces in one direction must be equal to sum of the forces in the opposite direction. In other words, the resultant force must be equal to 0. Then, taking moments at one point, and remember I said that to take moments at the point where you have very many unknowns, and since we don't have the we've just got the RB, since we don't have the the F, we may assume that we don't have the R, we can take moments about point B. And at this point here, we're given the angle to the horizontal as 60 degrees. This is 60 degrees, meaning that this angle here is 60 degrees, the same as this angle here, 60 degrees. So taking moments about point B, our frictional force acts at this point here along this direction. So the frictional force is passing through point B, the RB is passing through point B, so the distance is 0, meaning that the moment is 0. So this one will be this one will be anti-clockwise about point B, and then this one will be clockwise about point B. So we shall be having 17.5 G times 1.5 cos of 60 being equal to RA times 3 sine of 60. In other words, this one is going in this direction like this, and the perpendicular distance from this point B up to this point here. And since the angle is pointing there, then we use 3 sine of 60. So simplifying this, we shall get that our RA is equal to 128.76 newtons. Please do the substitution of G, and you'll find that that RA will be equal to that. So implying therefore that our frictional force is the same as, from this equation here, is the same as 128.76 newtons. Now the question wanted us to get the reaction at B. The reaction at B. So the reaction at B, we say that it is a resultant of the frictional force and the RB. In other words, our R is at an angle and vertically we have RB and then our F. So the reaction is at that angle there, and that is our tan alpha. So this is the same as 128.76 squared plus RB, which we got as we check 17.5 times 9.81. We got 171. 171.68. 171.68 squared, everything under a root, and this will give us 214.6 newtons. The angle will be equal to tan inverse of RB over F. Substitute, you get the answer as 53.1 degrees. And in case they ask for the coefficient of friction, if they ask for the coefficient of friction, we simply come and say that frictional force is given by mu times RB. So our coefficient of friction will be equal to 128.76. That's the friction divided by the reaction at B, which is 171.68, and get your answer as 0.75. All right.